In this video, we're going to look at some more compound probability. And the thing I want you to remember as you go through this is you really have to be careful as you think about the ands and the ors in the questions, right? So be careful with the ands and the ors. So let's take a look at this example. All right, so you're going to be given a table of data, right? So it says here, the table below shows some data about the 755 students who attend Northeast High School, right? So take a look a little bit here at this table, right? So this table shows two pieces of information, right? It shows students that are either male or female, and it also shows data about whether these students own smartphones, right? So if you kind of look at the way this table is organized, right, we could see that there are 370 males, right, 385 females, right? We know the total is 755. That adds up to 755. But more importantly, let's look at the individual parts of the table, right? So this right here would be saying that there's 240 people who are 240 students who are both male and also smartphone owners, right? This is saying that there's 130 people who are male and not smartphone owners, right? So male and female data go in this way, smartphone owners go in this way. Okay. If you need to pause to kind of digest how this table looks, feel free to pause and take a look at that. Okay. All right. So imagine that we go to this high school and we pick a student at random. Now, we're going to ask some questions about that student. So the first one, what's the probability that the student is male? Right? Well, if we take a look at this data, where do we want to look at? Right? We want to figure out the number of ways to pick a male out of the total number of ways to pick a student. Right? That would be 370 total males out of the total students, right? 370 out of 755. Okay? All right, you're going to do the next one. What's the probability that a student is a smartphone owner? Please pause and answer that. All right, the probability of a student being a smartphone owner, right? That would be 515 out of 755, right? Because what this table shows us that there's a total of 515 people who own smartphones, right? That's including the males and the females. So 515 out of 755. All right, let's do some more with this data, right? Two more questions, and this is going to be similar. I'm going to do number 3, you'll do number 4. 3 says, what's the probability that the student is female and not a smartphone owner? What's the probability that the student that we pick is female and not a smartphone owner? Well, if I look at my data, there's 110 that are both female and not smartphone owners. So this would be 110 out of our total, 755. Okay, please pause and do number 4. Let's check. Number 4, what's the probability that the student is a male and a smartphone owner? Right, so male and a smartphone owner. That would be 240 out of 755. Okay. We're going to do 2 more about the same data. And again, I'm going to do number 5. The first one, you'll do the second one. Okay. This one says, what's the probability that the student is a male or a smartphone owner? Right? You got to be careful with the ors. Okay. So the number of ways, first we got to figure out the number of ways that our student is either male or a smartphone owner. Well, let's take a look. How many are male? That would be these, 240 and 130, right? Those are male. That makes up a total of 370. Okay? But it says male or a smartphone owner. So we have to also consider the females who are smartphone owners. So it would be 240 plus 130 plus 275, right? It would be all 3 of these groups, right? The males or the smartphone owners, right? So we got to count all the males as well as the females who own smartphones, right? So if we add 275 plus 240 plus 130, that one's going to be 645 out of 755. Okay. One thing I want to caution you on that. Right? Some of you might have been thinking, oh, can't we just add all the males and all the smartphone owners, 370 plus 515? Well, if you do it that way, well, what would happen? You would count all of the 515 and you would count all of the males. But you would double count this group, right? You'd have 515 plus 370, but you would double count these, right? So if you wanted to do it that way, you'd have to do it this way. 515 plus 370, but then you have to subtract the ones you double counted, minus 240 out of 755, which still comes out to be 645, right? It's probably easier not to think about it that way, okay? So I just wanted to warn you that if you are trying to just add things up really quickly, you got to be careful. Make sure you don't double count. Okay, do number 6, please, on your own. That one's the probability that the student is female or a person who does not own a smartphone. Okay, let's check. Probability of being a female or a person who does not own a smartphone. Right? I'm sorry this is kind of messy, but females would be this. The 275 and 110, that's 385. Right? But then we also have to count the males who don't own a smartphone. Right? That's these. So that's 275 plus 110 plus 130. That's a total of, that's 515 out of 755. Okay. Okay, so let's take a look at another one. All right, this one is going to look overwhelming at first, but then you're going to see it's not that bad. All right, a theater is selling tickets for a performance of a play. There's an adult price and a children's price. If you buy your ticket 2 weeks ahead of time, there's a 15% discount. 200 tickets were sold for Friday's performance. 115 tickets were sold. 140 of the tickets were discounted tickets. 80 tickets were both adult tickets and discounted. Okay? All right, so this, and then we're going to ask some questions about picking a person at random and what's the probability of a couple things. Okay, but actually I'm not going to even go to these questions just yet. Right? Let's first focus on what the story is telling us, because there's a lot of information here. And what we want to do is kind of dissect this in a more usable way. All right, so I've taken away the questions. Let's just look at the story. Okay? And what we're going to do is we're going to create a chart, just like what we did in the other one. The other one you were given a chart. This time we're going to try to construct that chart. Right? So let's think about it. We know that there's 200 tickets sold. That's the total number of tickets. And we can separate those tickets 2 ways, right? You could either think about it as adult tickets and child tickets, adult versus child, but also you got to realize that some of those tickets were discount, some of them were regular. Let's see, discount and regular. Right? So we're kind of dissecting our information a couple ways, right? And then let's put our totals here. Right? So let's make sure you understand what this means, right? So there's a total of 200 tickets sold, right? That's our big total here. And then we know that some of those tickets were discount, some of those were regular, but also you could split up that 200 another way. Some of those were adult, some of those were child tickets. Okay, and let's use the story, the information in the story to kind of fill out this table. Okay, so we know 200 tickets, that's our big total. So everything added up has to add up to 200. Okay, let's see what else we know. 115 adult tickets were sold. So we know that the total number of adult tickets should be 115. Okay, we also know that 140 of the tickets were discounted tickets. So in other words, out of the 200, right, if we add up all the discounted tickets, that should add up to be 140. Okay, let me pause here before we go any further. Right, you should kind of already realize some information here that we can fill in. Right, for example here, right, we know that there's a total of 200 tickets. If there was 140 discount, well, how many regular tickets were there? There must be 60. Right, 200 minus 140 is 60. Another way of thinking about it, if there were 200 total tickets, 115 were adult tickets, well, how many were children tickets? Right? 200 minus 115, that must be 85. All right, these two have to add up to be 200. Same with these two. These have to add up to 200. Okay. All right, let's go further into the problem here. Now it says 80 tickets were both adult tickets and discounted. Right? So there's 80 adults who had discounted tickets. Right? Well, that would go right here. Adult with discounted. Okay. And now that's pretty much enough information to fill the rest in, right? We know that there were 140 discounted tickets, so if there were 80 of those that were adult discount tickets, well then that must mean there were 60 child discount tickets. Right, how about looking at it this way? If I know there were 115 adult tickets and there were 80 adult tickets who were discounted, well, how many regular adult tickets were there? Right? These have to add up to be 115. Right? So 115 minus 80, that's 35. Right? And then lastly, you can do it either way. You can think about the children's ticket adding up to 85, or you can think about the regular tickets adding up to 60. Either way, this is going to be 25 tickets here. Okay, so that's the first part of the problem, is just using that information, and then you can fill out this table. And once you fill that out, the rest should be easy. All right, so you're going to finish the problem now. Okay, so please, I copied the table over, made it a little bit neater. Now I'd like you to answer 7, 8, and 9. So go ahead and pause and do those, please. All right, so to finish off, let's see how you did. Probability that the person is a child, right? Well, how many total children are there? That is 85, right? So that should be 85 out of 200. Number 8, what's the probability that the person is an adult and someone who bought a regular ticket? So adult and regular, that's 35. So that'd be 35 out of the 200. Okay, and lastly, probability that the person is a child or a person with a discounted ticket. So we need a child, right? That's these guys. Or someone with a discounted. So we also have to include these discounted. Right? 80 plus 60 plus 25, that's 165 out of 200. All right, so we'll do some more of these in class.